Hello, everyone, and welcome to our webinar. Our topic today is titled Converting to Advanced Framing, from Experience. My name is Mary Ewer, and I will serve as the moderator for this session. Our speaker, Warren Hamrick, and I both work for APA, the Engineered Wood Association. APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered wood products. In addition to quality verification and product testing, APA conducts research to improve engineered wood construction systems and educates users and specifiers on the product's proper use and potential applications. Before we start today's webinar, I need to cover a few housekeeping details. Warren's presentation will last about 50 minutes. To ensure that everyone can hear it clearly, we have muted all participants. We do encourage you to submit questions by typing them into the questions pane on the control panel on your screen. We will take a break for questions midway through the presentation as well as at the end. We should have time to answer most questions, but if we run short, we'll be sure to post a Q&A summary along with a recorded version of today's program. We should have those posted on our website in a week or two. I'd also like to note that today's webinar is approved for AIA and ICC continuing education credit. About an hour after the conclusion of the webinar, an email will be sent to each attendee. It will include a link where you can get your customized certificates of completion. Our presenter today is Warren Hamrick, Engineered Wood Specialist for APA based in North Carolina. In that role, Warren works with designers, building officials, and builders on various engineered wood products that are used in buildings today and consults on engineered wood use in construction applications. Warren graduated from North Carolina State University with a Bachelor of Science in Civil Engineering. Prior to joining APA, Warren worked as a project manager for a structural engineering firm which specialized in commercial construction. For those of you just joining us, welcome to APA's webinar on the topic of converting to advanced framing, learn from experience. I will now turn the microphone over to our speaker, Warren Hamrick.
Thank you, Mary, and thank you to all that are joining us today. Our focus today is on converting to advanced framing and what we've learned, both successes and challenges from our past experience. As mentioned, this course is registered and approved by AIA, and credits earned will be reported to AIA upon completion. The course description that you all read when signing up for this presentation, I'm not going to read it all now, but let's just jump right into our learning objectives. We want to be able to fully understand what is advanced framing. We want to be able to learn how to use advanced framing to enhance energy efficiency, understand various advanced framing details, and take a look at some of the challenges to advanced framing conversion. Our agenda matches our learning objectives. So let's start out by looking at what I mean when I say advanced framing. The overall objectives of advanced framing can be summarized very simply into these four concepts. When I talk about advanced framing, I'm talking about any details that optimize material usage and energy efficiency, minimize waste and thermal bridging, and resist all design loads. There may be additional strategies that I don't mention today that fit into these objectives. Those strategies would also likely be considered as advanced framing techniques. Let's start out by comparing a conventionally framed wall with a wall that's framed with 2x6 advanced framing. So here's a typical short wall with a window, a T-intersection, and a corner. And this is how it would likely be framed with conventional framing. Note the intersecting walls and corners as well as the redundant cripples under the window sill. This is the same wall but framed with 2x6 advanced framing techniques. This image uses every aspect of advanced framing. By overlaying the two walls, one can really see the material optimization that occurs. At the same time, by optimizing the material usage, the wall cavity space for insulation is maximized, resulting in a higher whole wall R value. If we zoom out from the single wall, this is what an advanced frame building may look like. In this detail, we show 2x6 studs at 24 inches on center, and in this detail, the roof trusses line up with the second floor studs, which line up with the second floor joists, which line up with the first floor studs, which line up with the first floor joists. To keep in mind that advanced framing is a suite of details, you do not need to implement all of them to still consider yourself to be using advanced framing. One of the biggest challenges for framers is the move to stacked framing. So if we look back at this overall detail, we can see that everything is aligned at 24-inch stud spacing. Stacking your framing like this allows the option of going from a double top plate to a single, but this comes with added need for coordination. For some builders, sticking with a double top plate, which allows for random framing, may be the better option. Now, the great thing about implementing advanced framing is it isn't a take-all or leave-all strategy. Certain builders may choose to implement some advanced framing techniques while not incorporating others, or even incorporating them in phases to simplify the conversion process. A builder that does some advanced framing techniques is still building with advanced framing. Of course, the more holistic the approach, the more the savings. So let's break down this photo. So we immediately identify the ladder blocking T-intersection, which is an advanced framing technique. Looking closer, we also see raised heel energy trusses, and the OSB sheathing lapped over the trusses is part of a combined shear and uplift. However, note that the builder chose to say with 16-inch on center 2x4 construction for the exterior walls, with random stud placement and a double top plate. The idea that you can only do the pieces that are right for you is something we're going to explore a lot more as we discuss the challenges that people have faced while implementing these methods. Now that we know what advanced framing is, let's take a look at what's driving builders around the country to use it. There are four major advantages of advanced framing over conventional framing: energy efficiency, cost effectiveness, structural integrity, and sustainability. And we have found that most builders who have gone through the conversion process have been most focused on the first three advantages. Those first three advantages are something that every builder has to work to find a balance between. So finding a three-way balance between cost, energy, and strength is a challenge. Any of us can build a home that easily meets two of the criteria, but balancing in the third can be difficult. One of the things that's driving builders to explore options to find the balance is the change in the energy codes. Since the 2006 IECC, there's been a 30% savings in energy of each home built. These changing codes make finding the proper balance no longer a choice, but a requirement. The advanced framing details that we have and will discuss can be used to comply with the requirements of the IECC. This document that APA co-published with ICC provides 5 code-compliant options to meet the prescriptive R20 or R13+5 requirements. These assemblies allow the builder to use a cheaper cavity insulation to meet the IECC requirements and helps the energy code challenges to be overcome in a cost-effective manner. We also have a publication that shows how advanced framing details can be used to comply with the performance pass of the International Energy Conservation Code. A webinar with more detail on this publication is available for on-demand viewing on our website. Taking a slightly deeper look at how advanced framing affects the energy efficiency of walls, let's take a look at different whole wall R values. So we're going to start on the left side. The first bar is a code prescribed R20 wall. It's 2x4 framing at 16 inches on center and 1 inch of foam. In this example, OSB corner bracing was applied to 40% of the wall with a 1/2 inch of foam applied over it, as allowed by IECC section R402.2.7. With the framing factor, the whole wall R value is about 15.6. The second bar represents only a change to 2x6 framing and all OSB sheathing, so no foam. As you can see, the whole wall R value is already more than the code prescribed wall. Note that if OSB sheathing is not used on the first bar and you have 1 inch of foam applied everywhere, that whole wall value is about 16.8. So switching just to the 2x6 framing is about the same as a 2x4 wall with 1 inch of foam. The third bar shows 2x6 framing spaced 24 inches on center. The whole wall R value is increased slightly due to the reduced framing factor. And then the last bar includes stacked framing and single top plates, using full advantage of advanced framing to get the best whole wall R value. And just a note, if insulated headers are factored into the whole wall calculation, and we assume an additional 2 inches of R5 foam on the inside of the header, the advanced frame walls increase by an R value of 1. Advanced framing is so effective, it's even recognized by outside organizations. Many builders believe that Energy Star version 3 is difficult to attain. One item that must be addressed is thermal bridging. This is taken from the checklist required for Energy Star 3. 5 different methods are allowed to meet the thermal bridging requirements. You can have foam or insulated siding. You can have structural insulated panels, insulated concrete forms, double wall framing. And double wall framing is when you have 2x6 plates with staggered 2x4 studs. That way the insulation can weave through the studs. And lastly, advanced framing. So yes, advanced framing meets the Energy Star 3 requirements for thermal bridging. In order to meet the Energy Star requirements, corners must be insulated as well as headers. Cripples limited around windows and exterior doors, and interior-exterior wall intersections have to be insulated. In the warmer climates, stud spacing can remain at 16 inches on center, and 24-inch on center studs are only required in climate zones 5 and above, where 2x6 walls are likely to be used. Energy Star does not require a single top plate in any wall system. Advanced framing is about the only green building concept where real green can actually be put back into your wallet. And that's because it's more resource efficient. You're going to use less lumber. You reduce your framing labor. And then other trades will save time as well, as listed on the slide. And finally, with less waste, there would be lower dumpster costs. Now that we know what's driving people to make the change, let's take a look at some of the challenges. One of the main challenges we hear from builders relates to learning how to sell advanced framing methods to homeowners. Homeowners are used to studs being spaced at 16 inches on center, and the transition to 24 inches makes some people feel that the walls are not as strong. We've looked at the structural integrity of 2x6 advanced framing, so let's take a look at what we've found. Let's review the differences between a 2x6 wall spaced 24 inches on center and a 2x4 wall spaced 16 inches on center. This comparison involves looking at loads in 3 directions as well as both the studs and the wall sheathing. So I'm going to start with a comparison of the studs, starting with loads normal to the wall. And normal loading is indicated by the red arrow. A direct comparison of the 2 framing methods shows that the former, which is the 2x6 at 24 inch on center, is 2.5 times stiffer and 1.4 times stronger when impacted by wind loads perpendicular to the wall. And there's a 5% increase in the wall strength when looking at compression perpendicular to the grain. And this is at the sill and top plates. The studs are also 2.05 times stronger in axial compression when looking at 2x6 at 24 versus 2x4 at 16. The studs are only one part of the wall framing picture. So when comparing 2x6 at 24 to 2x4 at 16, it's important to consider not only the stud strength, but also the wall sheathing. The next item we're going to consider is the wood structural panel when used to resist out-of-plane wind loads. The code has requirements for resisting such loads, which are most typically experienced as suction loads during high wind events. The sheathing must comply with Table R602.3 (3) from the IRC. 2x6 at 24 with wood structural panels does comply with this requirement. The final structural consideration when looking at 2x6 studs at 24 versus 2x4 studs at 16 is the performance of the walls as it relates to lateral loads. As a general rule, wood structural panel shear wall and wall bracing performance depends primarily on the sheathing thickness and the perimeter nailing of the panels, not the stud spacing. So if your home is designed using IRC wall bracing provisions, there's no change to the requirements or strengths with 2x6 at 24 inch on center versus 2x4 at 16 inches on center. If your home is designed with engineered shear walls, the tabulated shear wall values remain unchanged. There are a couple of footnotes that are in APA's Engineered Wood Construction Guide. They refer to Table 23. So footnote J in that shear wall table, that allows for increased shear strength that would no longer apply with 24-inch on-center framing and may affect some engineered designs. And this footnote only applies when panels are installed with the strength axis parallel to the studs, so when the panels are installed vertically. On that same table, in addition to footnote J, footnote C requires a tighter nailing pattern in the field when studs are located at 24-inch on center. So at this point, we've considered the loads in all directions and the strength differences of the studs as well as the sheathing. The comparison shows us that while there are a few items that require attention, overall the design of the wall is not affected when going from 2x4 at 16 inches on center to 2x6 at 24 inches on center. So if you remember, we started this challenge as a homeowner perception issue. And what we found in the field is when you go from 2x4 studs at 16 inches on center to 2x6s at 24, the walls actually look stronger. Now, we have had feedback that interior non-load bearing walls that are 2x4s at 24 inches, so you space your non-load bearing 2x4s out to 24, which does happen in the field. We've gotten feedback that that does look weak. And for this reason, we recommend leaving all 2x4 walls, even non-load bearing ones, at 16 inches on center just to overcome this homeowner perception. So we've already covered quite a bit of material, and at this point, I'm going to pass the microphone back to Mary, who's been monitoring questions.
Thank you so much, Warren. You're right, that is a lot of information, and we have had a couple of questions come in. The first one is, are there any problems with building code officials approving advanced framing?
You know, a lot of these details are right in the residential codes, and there's an item with the single top plate that I've run into some confusion in the field, and we'll get into single top plate details in a lot more detail later in this presentation. That's the only area of concern that I've gotten. You know, for the most part, just to directly answer your question, no. I've had very little to no issue with building officials having an issue with advanced framing.
Wonderful. So I heard you say a lot of the details are code prescribed, and that's in the IRC legacy codes?
Yes.
Wonderful. Another question that came in is, when you talked about the axial strength of the 2x4 versus 2x6 stud, do you know what stud height was used in those calculations?
Yes. So just a brief refresher, we talked about the axial compression between the 2x4 at 16 versus the 2x6 at 24. And the 2x6 at 24 was actually 2.05 times stronger than the 2x4 at 16, and that was tested at a 9-foot stud height.
Great. And then the last question that we're going to get into today is, or during this mid-session break, the last one that came in is that you mentioned an increase in compression perpendicular to the grain when you compared 2x4 at 16 versus 2x6 at 24. Can you expand on that and explain a little bit more what that means?
Sure. So this performance increase is referring to the wall plates, and they're in compression. So just a little background, wood is weakest when load's applied perpendicular to the grain. So when that wall, if you think about that wall being loaded vertically, so obviously it's being loaded from the top of the wall, and the wall plates directly under the stud ends are being compressed perpendicular to the grain. And there's slightly more area of a sill plate when you go to the 2x6s. So you got a 2x6 sill plate versus a 2x4. And that, because there's slightly more area, it performs about 5% better under this load condition.
Wonderful. Wonderful. That makes a lot of sense. I appreciate the clarity there. Those are the questions that we've had come in from the audience so far at this midpoint break, but I certainly do encourage everyone to please continue submitting your questions, and I will continue to monitor, and we will go through a few more questions at the end of the session. Thank you, Warren.
Okay, let's move on. So one of the most difficult parts of implementing any new system is to ensure that coordination is done properly. So this includes coordinating with all of the trades that will be working on the home, as well as discussing it early on with designers. And when done properly, everyone will know before they start how to best implement advanced framing, and they'll have an opportunity to ask each other questions in the planning stage. And advanced framing techniques can be implemented in existing designs. However, there are some additional optimizations that can be done with advanced framing in mind during the design phase. So first, if you think about the placement of your openings, they can make a difference in the number of studs required and the size of the header required. So planning during the design phase can allow you to optimize your lumber use at the jack and king studs, as well as eliminate redundant cripples under the sills of windows. If your design allows your windows to be placed at 24-inch spacing, it helps not only with the optimization of lumber, but also with other trades being more efficient with time and materials, such as having full width bays for insulation. And we know it's not possible for all windows and doors to be placed at a 24-inch module. So when that number can't be hit, builders who have already implemented advanced framing have found the easiest way to frame. So the area of these walls I want you to focus on is the cripple studs under the windows. If you have, for an example, a 32-inch bay, instead of framing two 16-inch bays, frame one 24-inch bay and one 8-inch bay. This allows your insulation installer to buy only 24-inch wide insulation and cut one piece instead of two. And while this may seem like a small detail, it can have a big impact in material optimization. This optimization can be seen by comparing these two photos. The one on the left has three 24-inch spaces and one small space. So that's going to require only one piece of insulation be cut. The one on the right has two small spaces requiring twice as much cutting and potentially creating more waste. So making changes like this really show that you're thinking about how to optimize all materials and processes. If you think back to our structural integrity discussion, you'll remember that we talked about the effects of 24-inch stud spacing on the sheathing when the walls experience suction loads. What we didn't discuss was the effect of this spacing on the siding. The ability of wood structural panels to serve as a nail base for siding with 24-inch on-center framing is something that has been studied. Some popular sidings are limited to a maximum nail spacing of 16 inches, and we wanted to make it as easy as possible for builders to make the switch to 2x6 advanced framing. APA has a publication that provides information on using the wood structural panel sheathing as a nail base. So let's take a look at what using your wood structural panel as a nail base requires. The table from this document provides a substitution schedule for nailing directly to the sheathing in lieu of the studs. So when looking at this table, it's easy to see that the simplest answer is to replace your smooth or screw shank nails with ring shank nails, and then no additional fasteners are needed. The simple switch to ring shank nails allows the installer to miss every stud and use the sheathing as a nail base and still get the same performance that they're used to. If that doesn't work, it is possible to increase the number of smooth or screw shank nails instead. The ability to use your wood structural panel wall sheathing as a nail base becomes extra important as details like California corners are implemented. So framing your corner as shown on the left instead of the right, it eliminates an uninsulated cavity in the wall, which could act as a cold or a hot spot in a home. It also makes it more difficult for the trim installer to hit a stud. So there are a few other places where insulation installers need to be trained so that they can fully take advantage of the advanced framing methods you may be using. Ladder blocking can also be used at interior wall intersections. In conventional framing, there would typically be two full-height studs placed in the exterior wall with a void between them that's very rarely insulated. Ladder blocking uses less than half the lumber and provides a full-height cavity for insulation with just slight compression at the blocking locations. Insulation installers should be trained to install one piece of insulation behind the blocks and cut the insulation above and below each piece of blocking to maximize the area covered by full depth insulation. If you wanted to eliminate the ladder blocking and the need for the insulation installers to have the added complication, there is a detail that might work for you. So this detail is courtesy of the Home Innovations Research Laboratory. Some builders have had success with this detail, leaving a space between the exterior wall and the interior partition, such that drywall can be slid behind the intersecting wall, and this provides the most insulation at intersecting walls. Another place insulation may be different is at the headers. The IRC allows for the use of single-ply headers. They should be sized appropriately for the loads and size of each opening. To properly frame the window and support the wall above, an additional 2x6 must be placed on the top and bottom of the single-ply header. And there are also some proprietary products that are likely available in your market that are pre-insulated, and check with your local suppliers for their availability. Single headers can be placed at the top plate, as shown here, or at the head of the opening, as seen here. This header has a short wall framed above it to accommodate the geometry of the design. While single headers are the best option for providing insulation, if they are not able to be used due to structural requirements, another option is to use a double header. While this does reduce the amount of insulation in the header, it's still better to fit in whatever insulation you can, and a double header and a 2x6 wall provides 2 inches of space for insulation. For larger openings, properly sized structural composite lumber or glulam may be the best option for strength and providing a cavity insulation space. This is a method to eliminate the jack studs at openings, and it's using a header hanger. Again, this would optimize material usage and provide for more cavity insulation. One thing to keep in mind with this is the metal connector could create a thermal bridging concern. Panel box headers are another great option for headers, which provide full depth cavity insulation. With wood structural panel wall sheathing on the exterior of the wall, proper nailing to the framing members can create a box header. This one-sided wood structural panel box header can be a great choice for single windows or all openings up to 60 inches wide. We do want to note a few requirements for this. First, 15/32 category panels must be used. So commonly, 7/16 category panels are used for wall sheathing. And if that's the case, the 15/32 panels could be used only where box headers are designed. And the minimal thickness difference, it shouldn't cause appearance issues with the water-resistant barrier and siding over top of the sheathing. Another note is the strength axis of the panel used in all panel box headers must be placed across the opening, so it must be installed horizontally. If you're using vertical sheathing for the rest of the home, it only needs to be changed at the header locations. Nails must be 3 inches on center at framing members at the header location to create these box headers. And lastly, you can have no splices in the top plate occurring inside the header area. To get the same concept as the wood structural panel box headers, but with a bigger span, it's possible to place headers in the rim board space. The detail shown here provides the maximum insulation in the wall cavity while meeting all structural needs. The rim board must span past each side of the opening about a foot and be continuous. There may also be a requirement for joist hangers, as shown here, if there's not enough bearing length left on the top plate. The correct decision for which header detail is right will differ for every builder, and we work with builders who use each option. So far, we've only discussed what insulation installers need to know about wall insulation, but let's take a look at roof insulation as well. So when a standard truss is used, the ceiling insulation is compressed over the wall top plates, which would be as shown in this detail. On the other hand, if we look at a raised heel truss, you can see that the heel allows for the insulation to remain uncompressed over the wall top plates. The Energy Code recognizes this detail as an advantage and provides an allowance for reduced attic insulation when it's used. When raised heel trusses are used to meet this requirement, uncompressed R30 insulation is deemed to satisfy R38 requirements, and uncompressed R38 insulation is deemed to satisfy R49 requirements. Raised heel roof construction requires an insulation depth of 10 inches for most R30 insulation and a depth of roughly 12 inches for R38 insulation. A raised heel truss also provides a method of attaching the wall sheathing to the truss, which may provide uplift resistance and may help eliminate or reduce the need for additional metal hardware. And this should be verified by the designer of record. So all of the details that we've talked about so far require coordination with the framer in addition to other trades. There's one area that only requires framer training, and that's wood structural panel wall sheathing installation with 24-inch on-center stud spacing. First, no matter what your stud spacing is, make sure that wall sheathing panels are fastened 6 inches on center along all edges and 12 inches in the field of the panels. Or if you happen to be in a high wind area, fastening should be per the local code requirements. It's also extremely important that the panels be spaced a minimum of 1/8 of an inch along all panel ends and edges. This becomes more critical when panels are installed over framing spaced 24-inch on center, as they could be more susceptible to out-of-plane buckling. And where you really have to worry about this is when the panels are exposed to high levels of moisture. Use a minimum 7/16 category wood structural panel when applying panels parallel to studs spaced 24 inches on center, or apply panels perpendicular to studs as shown on the left. And it bears repeating that in order to minimize panel buckling, it's very important to follow APA recommendations for panel spacing and to limit the exposure to moisture when installing sheathing. And that applies whether your studs are at a 16 or 24-inch spacing. So this photo was used earlier when we were talking about cripple studs not being ideally spaced. I now want to point out the light showing between the wood structural panels. Some may think this is an issue, when in actuality, this is a very good thing. These panels are spaced properly and will be able to expand as they acclimate. When we see panel buckling in the field, it almost always comes down to the panels being restrained, and that's often by lack of spacing. And when they're restrained, they're unable to expand as they acclimate. And just one further note on this wall, if these panels happen to be brace wall panels and acting to satisfy the IRC wall bracing requirements, then they would likely need to be blocked along the panel edges. And it's very possible that the blocking, if required, just hadn't been installed yet at the time of this photograph. In some applications, like with the use of stucco cladding, it's important to pay attention to the strength axis of the panel. And that's going to be, it depends on what panel thickness you're using as well. So the strength axis of most wood structural panels is in the long panel direction. When applied parallel to the wall studs, which is a very common code permitted practice in most areas of the country, such panels are oriented in their weakest direction. For that reason, some recommendations, again, such as for stucco, call for horizontal panel applications or thicker sheathing when applied parallel to supports. The biggest issue for framers comes in the difficulty of doing things differently than they always have. One of the biggest challenges for framers is the move to stacked framing. So if we look back at this overall detail, we can see that everything is aligned at 24-inch stud spacing. Stacking your framing like this allows the option of going from a double top plate to a single. So let's take a look at what that's like. When a single top plate is used, which does require inline framing as we've discussed, the IRC calls for a metal top plate splice as shown whenever there is a splice. It may be possible to substitute wood cutoffs in lieu of the code prescribed metal splice plates. With proper nailing, these can splice a single top plate. The use of wood cutoffs optimizes material uses and minimizes waste. And by placing the splice below the plate, it's also easier to inspect. Splice plates are also required at T intersections. Shown here is the code prescribed metal plate and the lumber splice alternate connection. And the same concept is true at corners. Shown here is the prescriptive metal splice plate at a corner and the use of a lumber splice. In this instance, the lumber splice would be placed on top of the plate to avoid the studs at the corner. The splice can be moved inward if necessary to avoid rafter connection. The second challenge with going to a single top plate is the need for alignment and the IRC offset allowances. As mentioned, this requires inline framing so that the loads stack. However, there is a small amount of offset allowed with single top plates as shown here. The members above the top plate need to have no more than a 1-inch center-to-center offset from the studs below. Note that when conventional rafters with ceiling joists are used, the 1-inch maximum offset applies to both members, which makes this layout less forgiving than if you're using roof trusses. Switching to a single top plate can be a savings in the overall framing package. However, if a builder sticks with double top plates, the offset rules are simplified. So when 2x4 studs are spaced 16 inches on center and you're using a double top plate, there are no offset limitations. Framing can truly be random. Likewise, when 2x6 studs are used at 24 inch on center, which is what we've focused on today, and you continue to use a double top plate, there is also no offset limitation. And again, framing can be truly random. When 2x4 studs are spaced at 24 inches on center with a double top plate, there is an offset limitation of 5 inches for load-bearing walls. When using stacked framing, your floor joists are also going to be placed at 24 inches on center. This detail has both advantages and challenges. So first, the advantages. The wider joist spacing provides big cavities for HVAC and other equipment to be run. The switch to wider joist spacing typically also requires switch to a deeper I-joist, which will allow for larger holes in the web. These larger cavities and bigger web holes simplify the process for the HVAC contractors on site. Now for some of the challenges. When the switch is made to a 24-inch joist spacing, it's important to pay extra attention to the finished floor that will be installed. Both APA and the National Wood Flooring Association recommend making the switch to 7/8 category floor sheathing under hardwood floors at a 24-inch joist spacing. This sheathing provides additional stiffness to the floor system, which also improves performance. One of the more common questions that we hear when we talk about the thicker floor sheathing is the added weight for the framers to deal with. And what we found is the switch to 7/8, this has been completely a non-issue. On the other hand, we have heard some pretty positive things from framers about the lighter walls when advanced framing techniques are used. This home in Chicago was framed with advanced framing, and the framers loved how easy it was to stand these walls up. To ease the challenges faced by changing your methods, we recommend phasing in advanced framing. So here's a suggestion from the Advanced Framing Construction Guide for incorporating advanced framing in phases. The simplest method that grabs the most energy efficiency in a single step is the switch to 2x6 construction, and increasing the cavity insulation from R13 to R20. The next logical step is to go from 16 inches on center to 24-inch on center wall stud placement. So this is going to significantly decrease the number of studs required and thereby reduces thermal bridging, providing a higher total wall R value. By sticking with the double top plate at this phase, stacking of framing members is not required. Many of the other techniques can be implemented as possible, including advanced framing corners, T-intersections, headers, and window framing. The last step, which many builders take, and also many builders purposely stay away from, is to go to a single top plate. If you're going to do that, all framing must be aligned, and this makes coordination very critical. The savings in material and whole wall R value can make this worthwhile. Another concern for eliminating the double top plates is the pre-cut stud length is short by 1.5 inches. And some builders have successfully managed this by purchasing pre-cut studs at the desired length from component manufacturers. So back to our agenda. We've covered what is advanced framing. We've covered why it's used and some of the challenges that have been overcome. So for the last few minutes, I'm going to talk a little bit about culture. In the February 2012 issue of Professional Builder, an ongoing monologue on lean construction by Scott Saddam addresses what he refers to as a culture of lean. And I believe that advanced framing is a part of lean construction, and that the concept of culture is critical to successful implementation of advanced framing. Saddam spent years in the manufacturing industry where lean had swept the marketplace. As VP of Quality for Pulte Homes, he brought the concept of lean into the home building industry. Now Saddam consults with builders across the country and internationally on implementing lean concepts which save builders time and resources by reviewing processes, materials, and methods. It's not about dumbing down the house. The same quality house can be built with less. In this article, Saddam mentions that some builders get it. For advanced framing to take hold in a company, it must be part of a culture that is top-down, from the CEO to the framer. A CEO cannot simply say, let's do advanced framing and have it work, unless everyone in the company gets it. We already discussed properly sizing your headers, but when you're truly thinking lean, every opening would be addressed. That means eliminating headers in non-bearing walls. And reducing redundant cripples under sills of windows. And even making sure to use scrap material whenever possible. This builder cuts all of his scrap material, all of his scrap lumber, into 24-inch sections for use as ladder blocking, and saves scrap OSB from window cutouts for use as an air barrier at attic knee walls. It's amazing how just a change in the way you think can add to a cost savings that wasn't expected. By utilizing scrap materials, this builder has significantly reduced his dumpster costs. APA has worked with multiple builders on how to make advanced framing work best for them. One such example is highlighted in the case study shown here, which can be found on our website. In this instance, the builder, Stucco Building Companies, utilizes 2x6 studs at 24-inch on center and promotes the energy savings that can be seen to his home buyers. This case study also dives into the planning and coordination that took place to ensure a successful conversion. All of the details that we've discussed and more are available in our Advanced Framing Construction Guide, which is available for download on our website. Many of these details are found prescriptively in the IRC, and we worked with NAHB's Home Innovations Research Laboratory on some of the details to assure consistency. Additional information on advanced framing, links to other APA publications, and the new program site for professional designers, APA Designer Circle, is available through our website, apawood.org. All of the details are also available in CAD format on our website, apacad.org. So thank you very much for attending. And at this time, I'm going to turn it back over to Mary, who's been monitoring questions.
Thank you so much, Warren. I really appreciate all of that great information that you've provided us. We have had quite a few questions come in. People definitely listened to my call for questions, which is great. So we will get through as many as we can here in the next couple of minutes. We had a couple of questions come in related to exterior cladding. Does the spacing of studs further apart impact the type of claddings that can be used?
Yes, it can. Sorry about that. I had to get a quick drink of water. Yeah, the spacing of the studs can impact the types of cladding, and that is a really good advantage of having wood structural panel wall sheathing. It can be used as a nail base. So a lot of vinyl sidings require a minimum 16-inch fastening, and the building code does recognize plywood and OSB as a standalone nail base, as we covered. You do need to check, depending on the type of fasteners you're using. If you're using ring shank fasteners, you don't have to do a conversion. It will perform at 16-inch on center spacing. Then if you look at a cladding system like stucco, structural wall sheathing is recommended to increase the stiffness of the wall. But to ensure adequate stiffness at either 16 or 24 inches on center, we recommend, the panel recommendations are in table 24 of the APA Engineered Wood Construction Guide, which is form E30. So it can have an impact that does need to be looked at.
Wonderful, thank you. So it sounds like it's definitely something to keep in mind, and it goes back to that coordination issue of just making sure you know how it might affect your system, but there are lots of ways to make it work no matter what your finish is.
Right. And that's, that's something that needs to be looked at, whether you're at 16 or 24.
Wonderful. Wonderful. I also had a question in here. I'm trying to group questions into like groups that mentioned that often studs are missed even with nailing even when studs are at 16. So moving them to 24, it sounds like as long as you have that wood structural panel, that may not be a concern.
Yeah, and that's the huge advantage to the wood structural panel, acting as a nail base, as well as, when we're incorporating these California corners, it can be a little more difficult for some of the trim attachments, and having that wood structural panel as a nail base is really helpful with that as well.
Perfect. Um, I have a question or a comment here. I think somebody's just looking for a little bit of clarity that you mentioned that the lateral stability of the structure is most affected by the attachment at the perimeter of the exterior wall sheathing. Can you expand on that a little bit for me?
Yeah, if you're using wood structural panels as your wall bracing, then the majority of the shear, what's going to affect the shear, really breaks down to the fastening along the edges of the panels and the thickness of the plywood or OSB, and that is, that's made clear by, if you're designing per the IRC wall bracing provisions, and you're using wood structural panels, going from a 16-inch space to a 24-inch space does not change your wall bracing requirements. So that really clarifies and highlights that what's really critical is that fastener spacing along the panel perimeter and the thickness of the panel.
Wonderful, wonderful. When talking about structural integrity, we compared 2x4 at 16 inches to 2x6 at 24. Do you have, or what information do you have off the top of your head that compares 2x6 at 16 to 2x6 at 24?
For which loading?
For any, can you give general rules there? That question came in a couple of times. So I think, in some of the colder climate zones, we try to make everything as nationwide as we can, which obviously that doesn't work in all situations. So in some climate zones, they're using 2x6 already at 16. Can they still go to 24? How does that affect them?
I do not know. I'm not sure on that. I think you would have a slight reduction in strength in some directions, but I believe, and we'll clarify this in the Q&A that we post, if you're designing per the IRC, I think you should be able to go to the 24-inch spacing without an issue.
Wonderful. That's my understanding too. As long as you're designing per the IRC, obviously, if you're working with an engineer, talk to your engineer about it. But my understanding is that as long as you're per the IRC, no matter where you are in the country, it shouldn't be a big deal. But we will make sure to clarify that one on our posted Q&A later.
I may have missed the first part of that. Yeah, if they're talking about an IRC design, then yes, you should be able to go to that 24-inch spacing and still meet those requirements. But we'll answer that clearly in the Q&A that gets posted.
Wonderful. And sort of along those same lines, a little bit different, but so we've talked a lot about IRC buildings. Can these details be used in either high wind areas or on really large buildings that maybe fall outside of the IRC?
They likely can, but if it falls out of the IRC, then that's when an engineer needs to be brought in, and that's when you're going to start looking at your shear tables and things like that. You're falling into a shear wall design at that point. So likely could be used, but it's consult with your designer.
Wonderful. Thank you so very much. That is really all of the questions that we have time for. So thank you very much, Warren. Before we do conclude, I'd like to touch on 3 quick things. We have a short survey, your CEU certificates, as well as upcoming webinars. We'd really appreciate receiving your feedback through the survey that you'll receive shortly. So please do take a minute to fill that out. Also, don't forget to download the AIA or ICC Certificate of Completion from the links in the follow-up email. That email will come to you a little over an hour after the conclusion of our webinar. And finally, make sure you're signed up to receive our APA Update newsletter so that you'll be notified of our next webinar, Frame It Right, on November 29th, as well as any future webinars and updates to APA publications and standards. To receive it, all you need to do, starting from the home page of our website, is to click on Sign in the upper right-hand corner of the page. In the menu that drops down, simply select Register. From there, you will need to let us know what you'd specifically like to receive, which in this case is the APA Update newsletter. I should mention that if you have technical questions on any topic related to the use of engineered wood products, don't hesitate to contact the APA Help Desk at the address shown here. Warren is just one of the field staff we have throughout the country. These talented people are available to assist design professionals, builders, and code officials. Their individual contact information can be found on our APA website, www.apawood.org. Please feel free to reach out and take advantage of this resource. As I mentioned earlier, a recording of today's webinar and answers to the questions that were asked will be posted at apawood.org in a week or two. And with that, I'd like to thank you for attending. Have a great day.